All right, good morning, afternoon, or evening. Delete as necessary. In our lesson today, we are going to be doing lesson 3.4, which is using a protractor. Our objective is to review the different types of angles and how to measure angles with a protractor. And if you've ever enjoyed the game of billiards or pool, you will know that, well, you may not know, but when you play pool and you're trying to bank a shot, angles are very important because the angle that you hit the ball off the side, off the bank of the side of the pool table is the same angle that it will bounce off. So it's something that's very important for you to know when you're trying to make some basic shots is to you have to make sure that your angles are correct to get the ball where you want it to go. Okay? And to sink the other balls into the pockets. But to be able to talk about angles, we need to know different kinds, and here they are. We have acute, obtuse, right, straight, and reflex angles. Notice one thing about each of these angles is they have a little identifier telling you what we're talking about and which part of the angles we're referring to. Each one of these has a little crescent indicating that if I'm asking you about an angle, I'm telling you which one I want you to look at. On the obtuse angle, the crescent means I want you to look at this side, but not this side over here. Okay, it's the area that makes the obtuse part, but not the reflex on the outside. Because every one of these sets of arrows makes two angles, at least two angles, depending on how many lines you have. There's one on the inside and one on the outside. And that little crescent, this little crescent right here that I'm tracing around with my finger, tells you which angle we're measuring. Okay, so notice, and even the right angle has the circle rather than having a little half circle, the crescent. Okay, and then of course, and what this means is it tells you which angle we're measuring. Okay, is it the acute angle in the interior, or is it the reflex on the outside? So this little guy tells you that this is acute, that we're measuring the acute angle, not the one on the outside. This one tells me that we're measuring the reflex on the outside, but not the one on the inside. And this tells me that we're measuring the obtuse angle, not the one on the outside. And then, of course, with the straight angle, it's all the same. That no matter what side you measure, it's going to be the same degree. Okay? And here's a little bit more detail with each. Let's start with our acute angle. It's any angle that is between 0 and 90 degrees. So you'll see any angle whose measures less than 90 degrees. So we have 18 degrees, 45 degrees, 88 degrees. So all are acute angles. And there's another way to notate it as an acute angle is between 0 and 90. And those are less than signs. They're greater than signs. So 0, an acute angle is greater than 0, but less than 90. Okay, greater than 0, but less than 90. So in between. So 0.1 or 0.0001 is an acute angle, whereas 89.9999 degrees is also an acute angle. Once you get up to 90, though, it becomes a different angle. Once we get up to 90 degrees, we have a right angle. So any angle that is exactly 90 degrees. So a right angle equals 90 degrees. Okay, put my little X in there. And we notate it with that little square. We make the square in the corner. That means it is exactly 90 degrees. Okay. All right, next we move on to our obtuse angle, which is any angle that is between 90 and 180 degrees. So the measurement, let me erase that. Any angle that measures greater than 90 but less than 180. So again, a 90 degree angle is a right one. So we have 90 degrees, and then we have our greater than sign. So it goes from it's greater than 90, our angle is greater than 90 degrees, but less than 180 degrees. So 179.99999 is an obtuse angle, not a straight line. So our examples are 95 degrees, 125, 175 degrees. All of those fit into this range between 90 and 180 degrees. Okay, next we have our reflex angle, which is any angle that is between 180 and 360 degrees. So here's our example of a 200-degree angle, okay, greater than 180, but less than 360. Okay, so that we notate that as this: 180 degrees. Our angle is greater than 180 degrees, but less than 360 degrees. Okay. And we have our straight angle, any angle that is exactly 180 degrees. So here's all of our examples. No matter which way it's turned, the bottom of the circle, the top of the circle, up vertical or diagonal, any angle that measures exactly 180 degrees. So it equals, our measurement equals 180 degrees. Okay, so now becomes the trick. How do we label angles? Okay, so remember that we had the symbol this. It's not the greater than symbol or less than symbol, it's the angle symbol. So that means the angle. And you notice there's that little crescent again, okay? There's that little crescent guy right in there, indicating which angle we're talking about. Let me erase that so it's not overlapping. But we're talking about this particular angle right here, okay? So there's going to be letters on each one of these angles that we're measuring. And if we're talking about the interior angle inside here, you need to go in alphabetical order, okay? The interior angle is going to be angle A, and we use the same case, ABC, okay? Now, if we're talking about the exterior angle, okay, the one on the outside, you don't go in alphabetical order, you go backwards, you go, so, oh, let me draw an arrow. So this one goes in here, okay? Let me zoom out a little bit, move this over. Okay, the angle right here is angle, make sure it's not looking like a greater than sign, CBA. So angles will have a 3-letter designation, okay? That's how you tell which angle you're talking about, okay? On the test, you'll see them give you this. And the Danger Will Robinson that I always get is that on the test, there's that little crescent right here that wants you to measure the angle, and students measure the one on the inside. So you need to pay attention to where these crescents are, because they tell you which angle I'm talking about. Okay, so now we are going to use a protractor to actually measure angles. Okay, so I've created a few angles. Let's look at them. Right. Bring my protractor down. Let's zoom in a little bit. Alright, let's see if I can make the protractor a little bit more of the right size. Alright, there we go. Alright, this is a little fitzy. This is pretty close as we're going to get, okay? So you notice that that's pretty much a straight line, okay? So this angle we will label with a dot on the angle. It's really hard to make a dot with your finger here. Okay, so this is going to be angle L, M, and N. So the measure of angle L, M, and N equaled 180 degrees. If we bring the protractor back up, you'll be able to, oop, I'm moving the wrong thing. How do I do that? Alright, So it's pretty much right on the straight line, and it crosses that on the 0. Okay. All right. So let me rotate my protractor. Let me zoom it small. Okay. Let me zoom in on this guy. I guess we're looking at one thing at a time. All right. So there's my dot on the line. There's my dot on the vertex. And here's my other dot. And this will be angle P R T. Okay. Sorry for the pause there. Okay. So we need to find the measure of angle P R T, which, remember, that means the interior angle. Okay. PRT equals something. So let me get my, I'll move the wrong thing. Let's get, oops. Where's my protractor? Okay. Come back, little protractor, and let's rotate you until we get it to be the right. Get it right on that corner and see where it. Alright, make it a little bit bigger. Move it down a little bit. Okay. And let's zoom in. Looking at this angle PRT, so I've got it right on that straight line, and you notice it's pointing to 110 and 70. Well, I know that the angle that I'm looking at, PRT, is the interior. It's the acute angle. So I can't pick the 110 number. It's an acute angle. I'm looking at the 70. Okay? So since it's an acute angle, let me move my protractor out of the way. Undo. Protractor. Oh, I keep hitting the wrong thing. Protractor. Goodbye. Okay. Angle PRT equals 70 degrees. Okay. Let's zoom out. Let's go to the next angle. Here we go. Okay. Whoop. Let me get my protractor. Rotate it around. Get that lined up. Got to be lined up on the 0 for the bottom part of the angle. Okay. And let's zoom in. Make sure that we're all set up accurately. Okay. Move it a little bit more. Boom. So it's right on that. I want to be as precise as possible. Okay. There we go. Okay. So let's move around a little bit. I didn't label it, so let's go ahead and label it now. So we have, there's the vertex down here. We'll do that letter D. Down here is going to be letter C. Up here is going to be letter, I'll put in capitals, E. Okay? So angle CDE equals, let's go back a little bit. Notice it's right above the 20. I'm looking right here, right above the 20, so it's on 21. Okay, it's just one more above the 20. So that's 21 degrees. Oops, let's move it back. 21 degrees. Okay. Again, go down to my next angle. Let's turn my protractor around. Get it on the bottom line. Try to get it, let's make it smaller, so I have more to work with. zoom in. Let's fine tune it just a little bit. Okay, good. Let's move it around. Let's see what do we get. Now, if I am measuring this interior part of the angle right here, what kind of an angle is that? Yes, indeed, it's obtuse. Okay. It's just a smidge more, so it's in line. Okay. We're going to do the best we can with our lining up and measuring. Okay, I know that's a fatter line than that's on the protractor. Oops, don't want to move that. Try not to change the angle. All right. So now I'm measuring that interior obtuse angle. So it's not, it looks like it could be, what, 16 degrees based on these numbers. But I know that I'm measuring this line, and then I'm going from 0 here. I'm counting around since it's obtuse this way, okay? So I go from 160, 161, 2, 3, 4. This would be 165 right here to 170. So let me label there's my dot, there's my next dot, and there's my last dot right here. Doesn't matter really where these are. We will do, this is angle T, U, and V, okay? Angle T, U, V equals how many degrees? 164 degrees, okay? And do I have one more? I do indeed have one more. Bring my protractor down. Let's zoom in some. Okay. Let's turn it this way. Oop, I brought my 21 with me. I'll have to erase that. If I can. There we go. Alright, let's fix my protractor. Alright, right there at the vertex. Let's see if I can make it a little bit bigger. But not too much bigger. It's right on 0. Now that's a really fat line, so it looks like it's going between. Right here, we're starting at 0, and we're counting. I want to see what the angle measurement of this angle is. Okay, so we're starting at 0. Here we're going up this direction from this bottom line up to the top line up here. So that's roughly about 90, 95, 96 degrees. So I'll be flexible with measuring by 1 degree, but you're going to have it easier to do with the geometry template and the lines on the test. It won't be nearly as thick as the lines I'm working with on this application. Okay, so this is going to be angle G, or letters G, H, and I. So I'm measuring angle G, H, and I, and I get it equals 95 or 96 degrees. It'll be a lot more accurate on the test, okay? So you always have to make sure that you're measuring from 0, depending on which angle you're measuring. If you always start from the bottom line, and then you work your way up to the next line. So you'll start at 0 and count. So it depends on which side you're working from, okay? Which way the angle is on your piece of paper. Now another protractor that we have is called the full circle protractor, okay, and that's what this guy is. Now, you notice it goes from 0 all the way around to 360, but there aren't any little increments on the inside. So this is definitely going to be used for like rounding to numbers if we use this protractor, okay? That we have to kind of do some estimating if it's in between 10 and 20, for example, okay? So let me go ahead and draw with my finger a angle, okay? So I have angle, okay? know it looks like scribbles, but just bear with me on that one, okay? I have X, Y, and Z, okay? So I want to find the measure of angle X, Y, and Z. Let me bring my protractor back over. Okay, now I have to make sure that I am on right on 0, okay? And get it as close to 0 as I can. All right, so X, Y, and Z. I start from 0, I start from 0 this way, I go all the way around, and I get to about 150 degrees. Okay, so X, Y, Z equals 150 degrees. Okay, now let me move my protractor out of the way. I can also measure angle Z, Y, X. Now, X, Y, Z was this side. Oh, Mr. Shanto. ZYX is, of course, right here. So it's the other angle. Okay. So what does ZYX equal? Okay, let me bring my protractor back. Now, if I know that a circle has 360 degrees, and I don't have another 0, I'm just kind of counting up by tens from 100. I'm going this direction. From here around to here, I would be counting up by tens up to 360, or I would just take 360 and subtract my 150 from my other angle, which would give me, get my protractor out of the way, not that, I want this to stay in this spot. All right, let's move this out of the way. There. Either way, there we go. All right. So if it's 360 minus 150, that leaves me with 210 degrees. Okay. All right, so that's using a regular protractor, a full circle protractor. Both of those are on your geometry template, and you have all of your different angles. Yeah. Angles have 5 different types: acute, obtuse, right, reflex, and straight. Each angle type has specific measurements, and use your protractor or geometry template to measure angles. Be careful, accuracy counts. It was really hard for me to demonstrate with my finger on the iPad, but you get the idea of what I'm trying to do. Okay? We'll go over it in more detail in class. Thanks.